Okay, so in this video, this is an introduction to resultant vectors. This is just explaining why we do what we do. However, in the following video, that's going to have more sort of exam-styled questions and sort of thing you would normally see. But let's just jump straight to it and see what occurs. So this first one, we've got an object moves for vector A, then moves for a vector B. State the vector of the entire journey A plus B. So I'm going to actually just draw these out first to try and give me an idea of what occurs. So first I'm going to do my vector A. So I'm just going to make a note of my starting point. And then I'm going to the right by 6 here. So 1, 2, 3, 4, 5, 6. And then I'm going up by 2. So 1, 2. So this journey here, that is my vector A. Then it moves for vector B, so it goes across by 3, so 1, 2, 3, and then up by 4, so 1, 2, 3, 4. So this journey here, that is going to be my vector B. And so I want to find out the vector of that entire journey that has just occurred. So I want to count all the way across. So I'm finding out now my A plus B. So I've gone across by 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've gone along by 9. And then I've gone up by 1, 2, 3, 4, 5, 6. So my entire vector is going to be 9, 6. However, that's quite a slow way to tackle it. The quicker way to do it is to actually think about our vectors. So down here, I'm going to just write out my A plus B, but this time I'm going to write out my vector A, which is at 6, 2, and I'm going to write out my vector B, which is at 3, 4. And what we should see is along the top, I'm expecting an answer of 9. Well, 6 plus that 3 is going to give me 9. And then 2 plus this 4 gives me that 6. So when I'm adding vectors together, I just add together their corresponding part of their component. So I add the tops together, I add the bottoms together, and when we get into 3D coordinates, we'll add the middle corresponding parts of the components together. So that's what I do when I add vectors. So let's take a look at this example here. An object travelled for vector A, then for vector A again for a resultant journey of 2A. State the components of 2A. So again, I'm going to just draw it out. So I'm going along by 3, so 1, 2, 3, and then down by minus 4, 1, 2, 3, 4. So this is my first bit of the journey, that first vector A. And then I do it again, so I go along by 3, 1, 2, 3, and then down by minus 4, 1, 2, 3, 4. And then drawing that out. So then having a think about what has occurred to that resultant journey of the 2A. I've gone across by 1, 2, 3, 4, 5, 6. And then I've gone down by 1, 2, 3, 4, 5, 6, 7, 8. So I went across by 6 and down by 8. So my total vector is 6, then minus 8. But once again, let's have a think about that vector A, because that is a bit slow to do it this way. So I'm going to write it as 2, and instead of that A with the underline, I'm going to put that 3 minus 4. And remember, when stuff are right next to each other, that means we're multiplying them. And if I do 2 times the 3, that's going to give me the 6. And if I do 2 times this minus 4, that gives me minus 8. So when I've got a number in front of my vector, I just multiply that number with each part of my component vector. And so in the next video, we'll use this in a more quicker method like this, and we'll look at a bunch of questions. But otherwise, let me know if you have any questions, and good luck with the work.